All right, guys, today I want to work through higher level section A from the 2013 exam paper. Again, it's 120 marks. You have to answer any 10 questions on it, but I'm going to go through it and answer all questions on it. It is a paper we've done before. We've nearly all of them done before now at this stage, so really it should be familiar to you now. And if you're finding anything isn't familiar and you don't recognize it, well then you haven't enough work done and we need to put more work in. So just zooming in there to start off, we are as usual answering question 1, and question 1 is always relatively easy. Now again, this is higher level, and higher level question 1 will always be labeling the parts. Okay, so question 1, fill in the label for each diagram by selecting from the given list. So we're given a series of answers there: acute, alternate, perpendicular and opposite. And what I would have done with you before is I would have said, right, first of all, it's process of elimination, but secondly, which ones do you already know? So if I look at the first one there, that's obviously perpendicular. Make sure you spell it right. Question 2, not so sure about at the moment. Question 3, I can see that that's an acute angle. And then I'm left with, I've used perpendicular, I've used acute, I'm left with alternate and opposite. So if I look at these here and I try and compare them, well, this has to be the opposite because they are opposite each other. And then that leaves alternate as the last one. No, this is more maths than TG, but there you are. Okay, so that's that one. Question 2 then. Figure shows the plan and incomplete elevation of a factory. And we are asked, sorry, now I'll just get this straightened. What are we asked to do? We are asked to, the roof spaced in a right angle triangle is shown in the graphic, complete the elevation. Okay, so first thing is this little bit of revision. If I draw a circle, any circle, anywhere, anytime, and more importantly, I concentrate on half of that circle. So in other words, a semicircle. So I'm just going to draw a random circle there on my sheet. All right, just putting it anywhere, it doesn't matter where I put it. The bit I want you to remind you of is that if I take the diameter of that circle, okay, so this is the learning here. Remember, we're not just doing short questions, we're learning from them. If I take the diameter of that circle and draw a triangle where the diameter is one of its edges and the point of the triangle touches the circle, that triangle will always and ever, and at this stage, this little sketch should look familiar. Certainly we've had it on the board often enough. There's a second one. The angle at the top between the two orange lines, between the two yellow lines and between these two green lines will always be 90 degrees. And if you don't believe me, look, there's my 90 degree set square, a 90 degree angle, 90 degree angle, and in the yellow, 90 degree angle. Let's try one more at the opposite side just to really test this. So it's from the edge of the diameter to any point on the circle, gives me 90 degrees. And if you're saying to yourself, why is she drawing that? Sure, I can see it. Yeah, I can see the 90 degrees. Okay, that's all very well, but how does that apply to this question? Well, how it applies is I need a 90 degree angle, and all I know so far about it, or about that 90 degree angle, all I know is that I can project up from here in plan, but I don't know how high or where to project to. So what do I need to do? Well, I need to draw me a semicircle. And the semicircle will allow me to draw the completion of this question. So the blue line there is the same as the blue line here, in the sense that not the same length, but it represents the same thing, the diameter of a circle. Okay, so that blue line is diameter over here. And that blue line is diameter there. So I have 2 points on my diameter. Anytime I have a diameter in order to draw a circle, I need to bisect. And yes, we need to be that accurate. Yes, you could measure it, but measuring it in this case isn't enough because you wouldn't be accurate enough. So I bisect, so compass is open slightly more than halfway, put the point of the compass at the end of the line, scribe an arc to each side. There we go. And where those arcs cross, join them. Lovely hurling. And that is the center point for the semicircle that I need. And now I draw that semicircle. I would normally keep it fairly light, but I want you to be able to see it there in the camera. So there it is, there's my semicircle. And the winning point, or the point that I am after, is where that point cuts the semicircle. That allows me to complete the elevation of the factory. So far, so good. Just put an arrow on that so you know when you come back and look at it. Okay, now that's the learning there. So this, and I did tell you at the time that this will come up somewhere either in short questions or in long questions. And there it is in the short questions. Please do not forget it. Anytime you see a 90-degree angle, your brain straight away should jump to that fact. Am I going to need to use the circle fact? All right, question 3 then. In question 3, we are, hang on, there's straighten up. Okay, there we go. In question 3, we're drawing a perspective, one of my favorites. With perspective drawing, it's a matter of extending on your lines to the 2 vanishing points. So on the left here, we have VP1. On the right, we have VP2. Okay, and I join those points down to the perspective. So I extend them back, and with vanishing points you are joining from the right and from the left. So I'm basically, to start with, just joining those back to the relevant vanishing points. And in a minute then I'll say, well, right, how much of those lines do I actually need? Don't know yet, but I will know shortly. So if I join the ones in the orange are going to the right, I'm going to do the green ones to the left, so VP1. I can also, just like this corner here is joined back to VP1, this corner would also be joined to VP1, okay? And same here with this roof surface, it would also be joined to VP1. And so far, that's as much as I can put in for a minute. So I can start heavying in some of this because some of it is done and some of it's already correct. So I can heavy in where these 2 points cross. There we go. Can I heavy in anything else just yet? No, but what I can do, right? And you might not have noticed this, maybe you have. They have given you a tip here because they have shown you these 2 lines already. And where those 2 lines cross over is going to give me the position for the vertical edge of the, what would we call it, the room, the porch, I don't know, the extension, the garage, I don't know what you want to call it, doesn't really matter what you call it, but what I do need to do is to put in those 2 lines, because once I have that line, then I go back to what I've already told you about perspective, which is the horizontal lines, or at least what would have been horizontal in a planned elevation, would be joined to the vanishing points, but vertical lines stay vertical. So in here with my sliding set squares, in order to keep it nice and accurate, I go in as far as my point, and I pick that point, and I put in a nice heavy vertical line, because that's part of the question. Lovely. And then, like I did a minute ago, those points can be joined back to VP1. Now, while I'm still doing this, am I supposed to start talking about question 1 and how fast that was to do in comparison to the last 2? Now, every exam paper will have, now it's not written down anywhere in stone, but you can check this in your own exam papers. It will have usually around 4 questions that are easy and very quick to do. And those questions are there to kind of help you get the paper done, but also to get you to the magic 40%. Because you answer 10, so if you answer 4 perfect, you've got 40% for short questions at least. Okay, so keep that in mind. Look for those questions. Seek them out. And then you only need to find 6 more. So while I'm answering everything in here, remember you won't necessarily answer everything on the day. Okay, so that gives me that point there. Lines that are vertical stay vertical, there they are. Oh, lovely. And I am nearly finished except for the tricky slope. Now, it's actually easier to deal with this slope than you might think, okay? It's on a gable end, right? So if you looked at down here, it's okay, how do I deal with that? How do I manage it? Okay, there's a couple of ways. One would be, and I'm not going to necessarily do it with you here now, but if you extended that edge up and extended up the right edge, they'd both meet at the same point. Now, we don't know where that point is though, so that's at the minute of no value to us. But what I can do is I can vanish back a vertical line, right? So if I imagine that this gable end is like one of them Tudor houses that has the vertical lines or the vertical edges painted on the side. What if I put in an extra, kind of a sort of a magic line, as if I was painting it down the side of the house, and I put it in vertical, because lines that are vertical stay vertical. And I say, well, right, there's a pillar at the front of the house, or a vertical line, or a painted line. It doesn't matter what you call it or how you think about it. But what I can do now is I know where it reaches the straight edge, and I have that, or the flat edge, the horizontal edge. And if I vanish it back, I can figure out, well, okay, there it is meeting that edge. Back it goes. This is where the same yellow line, or the same pink line or pink edge would appear. And again, staying with my sliding set squares and keeping it as accurate as I can. So it would appear there, and that gives me the point at which that roof surface vanishes. Because remember, there are no lines in perspective parallel. Vertical lines, yes, they stay vertical. So yes, you could say that they stay parallel. But every other point, 2-point perspective, the lines will go at an angle. Okay, and there we go. And that's that one done. Now, it took us a while to do that. There's a bit of time involved there. Next one, trying to move along fairly quickly because I don't want to make the video too long. Next one is question 4. Actually, what I'll do is I'll draw that in and then video it in a second. I'm going to move on to question 5. Actually, no, what I'll do with question 4, is I'll draw it in and just upload it as part of the solutions, because it'll just take too long. Question 5, what are we given? We're told that the graphic shows an advertisement on a newspaper page. Figure 1 shows a triangle that represents the area of the advertisement. Convert the triangle to a rectangle of equal area. So areas where we are, now we haven't done areas as a topic, most teachers don't, so I'm just going to cover this little bit first for you. And the only thing I'm going to say about it is, it's the whole theory behind this is based on the fact that half of the height multiplied by the base is the area of a triangle, and the height by the base, or the height by the width, or length by the width, whatever way you want to look at it, is the area of a rectangle. So what I have to do, if the triangle represents the area they want to use and I want to convert it to a rectangle of equal area, the easiest way to do it is to bisect this edge, this yellow edge here of the triangle. Now I've explained this one a lot in other classes and videos, so I'm not going to spend too long explaining the why behind this now today. But so I'll just give you the how. So I'm going to bisect there, scribe an arc to each side, scribe an arc to each side, lovely. And where they cross is my bisection, and that bisection line gives me the size of my advertisement square or rectangle. Now, without spending ages, as I said, explaining it, I do want to just mention something that I hope you can see by looking at it, and as to why this construction works. We have effectively, if I had a scissors here now, I have effectively cut that piece off and flipped it over and added it on there, and it has become the perfect area of a rectangle. Okay, question 6. Question 6, 3D graphic shows a playground feature. The top of the feature is based on a half ellipse, semi-ellipse. Figure below shows the location of the axes and the focal points. Point P is a point on the curve. Find the length of the major and minor and draw the semi-ellipse. Okay, so I know that I have 2 focal points. I know I have a point in the curve, and hopefully you know or you remember this particular fact. To find the focal points, find F1 and F2. Normally what we do is we take half the major axis on our compass and swing it from the end of the minor axis. So that's just a bit of revision. Now, that's one fact. The other one I want you to take note of, and let me just push this up for a second, is that F to P to F1 is actually equal to the length of the major axis. Do you remember in first year, or maybe to second year, it doesn't matter when, I brought in a board to the drawing room, and the board had 2 screws at the positions of the focal points, and it had a piece of string. And I put my pencil into the piece of string, and I drew round and round and round and round, keeping my pencil taut with a piece of string, and I got a perfect ellipse. And the reason I got a perfect ellipse was because the length from F to P to F1 was the major axis, and it generated both the major axis and the minor axis for me. So this is the question where it's this fact that is important. Now remember, whether we get this as a short question or not, this question is going to be somewhere in your paper, here or even in the ellipse question on the actual exam. So let's put that in there now. So what have I to do? Well, I can't figure out the major axis till I actually figure out the length of F to P to F1. Now we're not measuring and adding. I've told you that before. We're doing maths through technical graphics, but that doesn't mean you should ever find yourself adding something together. So first of all, well, I'll figure out what's the length from F to P. There it is, purple line there. And the length from P to F1. There it is. How do we add stuff in TG? Well, we literally add it on with the compass. So what I'm going to do is I'm just going to extend on that line, keep it light for a minute, and I'm going to say to myself, well, if I wanted to add the length of that line to it, what would I do? I would just come back here, measure to F, and I would rotate my compass up onto the point. And now the purple plus the orange. Okay, so the purple plus the orange is F to P to F1, which means now I need to bisect that to put it on the major axis. So here we go again, bisection, and then it's another long question. You know, these are higher level questions. This is one of the longest short questions. Which doesn't really make sense, but it is one of the longest set of short questions that has come up. But anyway, so I bisect it. Now, of course, there's nothing stopping me from drawing that line over there or somewhere like that and using that part of the page to bisect it. But here we go. So I bisect it. Why do I need to bisect it? Not because I'm drawing a semicircle this time. The dog is off again. But because I need half of the major axis. So there it is there. What do I do with that half? I put it at the center of the ellipse, swing an arc to the left, swing an arc to the right. There it is, major axis is marked off. Now how do I do the minor? Well, I go back to this one. take half the major axis on your compass and swing it from the end of the minor. So you've come up with that before, you've come across it before. So normally I take half the major axis on my compass, which is already set on my compass from there, and I would swing it from the end of the minor. My problem now though is I don't have the end of a minor, but I do know where the focal points are. So if I now take my compass and swing F, and from F over here, I just realized it's very easy to make a mistake there. There's my major axis. So major axis and minor axis. Actually, I should have said minor axis there and major axis. So there to there. Now you have to draw half the ellipse there as well. I don't think I need to revise that. You can go through it yourselves anyway in your own time. That is overdone. Now, the information contained in there though, that is well worth going over and revising and knowing it, because your long question, if it doesn't come up there in the short questions, you get something like that in the long question. All right, question 7. The figure shows the elevation and plan of a pyramid which is cut by VTH. The 3D graphic shows the cut. Complete the plan elevation of the cut. Now, when we looked at this before, you didn't like it. I'll be honest with you, I don't particularly like it either, in the sense that this is far more DCG. But having said that, I actually can ignore the VTH. And if I just imagine, and you've done things like this, if I just imagine that the object is cut like that at an angle, I need to find the view in plan for it. So in order to do any kind of a view, I'm going to number the points in my question. 1, 2, 3, and 4. So that means 1 is there, 2 is out the front, 4 is out the back, 3 is over here, and 0 is in the middle in there, missing. Now, if I look at it straight away, and I'm using side and set squares here as well to keep this accurate, I am going to go parallel to the XY line. There's the point on the trace, and I project that down onto line 3, 0. So I need to put in line 3, 0. And if I do the same at the other side, there's my second point. How do I finish that then? Well, this is the awkward one, or the slightly trickier one. 2 and 4, because it's on a straight edge, you can't project it down because you would be projecting it onto a straight line. The easiest way to manage it is, instead of projecting it down, it's move it onto the edge, move it over to the left hand side. So it's touching the edge of the object there. So I'm transferring it onto that edge for a minute, and I'm saying, right, if I transfer it onto that edge, where would it be in plan? It would be there, but it would also then move parallel to the edge bottom, because no matter where I cut a no matter where I cut a pyramid, if it's a horizontal plane is cutting it, if it's cut horizontally, you will always get parallel lines from the edge. So it's cut across there, and that gives me the third point. And I do the same over here. Okay. Now, so to finish it off, what does it actually look like? Well, this point is joined here. This point is joined to here, and here, and here. And make it as accurate there as you can. And of course, I should heavy in this bit. And this bit. Right. Freehand pictorial sketch. I'd consider that an easy question. Now just be careful. There we go. You're not drawing what's given there. You're drawing a 3D view. So that is important. 3D view is what's needed. Okay. Question 9, CAD commands. We've done them before many a time. Let me have a look and see what's happening. So if I say that's point, oops. if I say that's point number 1, number 2, number 3, and number 4, what's happening at number 1? Line command is used. What's happening at number 2? Smart dimension command is used, or dimension. 3, extrude boss or base, and 4 would be chamfer. Okay, moving on. Plan elevation and end view. Question 10. We're asked to, gives you a 3D graphic, project the elevation of the dispenser. That shouldn't be any bother to ye. Let's work through it anyway. So what do? I project up my points from plan. Trying to keep everything, again, as accurate as you possibly can. And I project across from elevation. Again, watching the accuracy. Now, I know you'll be doing this in your books at home, some of you. Others will be able to print it. If you can print it, it's a lot easier to answer these questions when they're printed. Okay, so in terms of heavying in at the moment, this one goes up, goes up. All right, what am I going to see if I look in there at that surface? Now, I'd consider this one of the easier ones as well, by the way, although it's not as easy as some. So I'd have a heavy line going straight up there. I would have a heavy line going straight up there. I'd have a heavy line straight across there through that edge. I would have a heavy line going across there. Oh, the dog's off again. Someone's obviously walking their dog a lot today. And the only extra line now there that is required, and it is quite important, is this sloping edge, and I nearly forgot about it. So this line comes across because this slopes down to this point. And let me just check a quick check over that. Indeed, that is my plan, elevation and end view. Oh no, it's not, because I haven't heavied in these two lines. That's most of it. There we go. All right, angles, you should be able to work out. 52 plus 52, 104. 104 from 80 leaves me with 76 degrees, so A is 76. B then, if this is 90 degrees in there, because they're shown as the angle, 90 plus 52 is 142 from 80 is 38 degrees. And then C, same story, 38 plus 90 from 180, so 90 plus 38 gives me 128 from 80 is 52 degrees. Tip for you, there's nothing to stop you taking up your protractor and measuring them, which is why you always need a protractor. So if you want to check whether you're right, wrong, or indifferent, what did we get for B? We got 38, did we? E did, etc. Okay. Graphic below shows a logo based on a racing car. Figure 1 shows the incomplete logo. Complete the logo by drawing a tangent between the wheels of the car. So we are asked to draw a tangent in there internally between the wheels of the car, and this is the one that I have to always stop and try and remember how to do because it drives me nuts. Right, and the reason it drives me nuts is it's basically the start of it comes down to the same setup each time, which is that you join the centers of the circles, you bisect them, you draw a semicircle. That's the same every time. So let's go ahead and do that, and then I'll talk you through the next bit. So I'm going to join the centers. I'm going to bisect them. I don't know how many times I've bisected today, but it feels like a hell of a lot. I'm going to bisect them. And I'm going to draw a semicircle. Now, this is the one where I need a whole circle. So I'm just going to draw the whole circle there because I'm not sure which side of that semicircle I need. Okay, so the setup is always the same. Join the two center points, bisect, draw a semicircle. Now what we're going to do though with that semicircle this time, or at least that full circle, is we are now, when you're doing an internal tangent, we're going to add the radius of the small circle onto the larger circle. So we're changing the question, and by adding on the radius, effectively, we're sort of moving the question slightly out away from the circles we're working on in order to generate the same parallel line. So in terms of adding, we're back to this. We don't do maths and TG, or at least we try to avoid doing maths and TG. So I take that radius, there it is. I add it on, and in order to add, like we had earlier on in some other question, the easiest way to add something is to extend a line somewhere, anywhere, it doesn't matter where you extend the line. So off it goes there, right? There's my extended line. I'm adding it on, so my compass goes down there at the edge of the circle. Oh, lovely. And it ends up almost at that same point. So that is a different point. Let me just put that in a different color so you can actually see it. That's a different point. So that's it added on. I then draw a circle using my new radius. So there's my new radius. It's the center of the original larger circle with the added smaller circle. And now where that circle crosses the semicircle, that is going to be my solution, or at least it's going to give me one of my points of contact. So point onto the outside. There it is. There's my point of contact. And in order to get the point of contact at the opposite side, then I use slide and set squares. So let me just put that in tidily correctly. I use slide and set squares to bring the same point back, and where it cuts the circle line, that is my tangent. And then of course don't forget to draw the tangent. Okay, nearly there. So that's an internal tangent. Question 13. What are we asked? 3D graphic shows a plate rack, also shown as an elevation of the plate rack and the plate. Draw the plate position on the rack and show all construction and point of contact. This is quite an easy one to my mind. Just be careful. We know what the radius of our plate is. So what we need to do is add the radius onto the edge of this circle and add the radius onto the edge of the other. So similar to what we did in the previous question. So I'm just going to draw a line out from the edge there so that I can do that whole process. And I'm going to draw a line out from the edge there. It doesn't matter what angle I do it at or where I draw that line. It just needs to start from that center point. I'm going to take the radius of the plate. There it is. And I am adding it. So my compass, be careful so that you can see this. My compass is there at the edge of the plate. Can you see? You can. There it is, added on at that side, added on at this side. Then, and there is only a tiny difference between these measurements. Go back, put it now into the center of the circle. Take this on your compass, swing an arc over here. It's the same size. Actually, I probably didn't even need to add it on at both sides. So swing a second arc, and where the two of them cross, you should be able to turn your compass around and draw in that plate, just touching off those two teeny tiny little circles. And there we go. Okay. Where are the points of contact? They are on a line joining the two centers. There and there. Okay. Question 14. We're finally nearly there. Knife block. I remember doing this one with you before. Show the true shape of surface S. Well, we don't have to worry too much about it because it's already set up. But this question is the one where I said to you the easiest way to manage it is to imagine turning the page so that the question is facing this way. And then drawing your elevation. So what I'm going to do, I'm on side and set squares again. I'm setting up my set square to the XY line. There it is. Actually, I should go the other way, sorry. That way. Setting it up to the XY line. Going over here to the plan. And just take note that the XY line is also parallel to surface S. So I bring up my points from plan. And when I say my points, I mean every point in plan. I find it easier to do this surface by surface. But today I'm not going to do that because of it being sliding set squares. It'd be hard to keep it accurate. So I'm just going to bring up every line first, which makes it a little bit more confusing. However, we move on. What isn't confusing though is the fact that heights and elevations will always stay the same. So if I look at my front surface here, it's this surface there in elevation. This is just another elevation because both of them are coming off the same plan. So if I take the height of my compass for this edge, and there it is, and follow that up along, it would appear here. Oops. Here. It would appear on this line. The same heights. That's the end of that. This point over here at the front is on the lower edge. So the point for there would be at this edge. And then the other height, if I mark it in, would be from the XY line to there. Follow it over. I'm talking about this point here. So first of all, my actual surface S, it's getting dark here now, it's hard to see the lines. But anyway, my surface S appears there. And this will be heavy. Now, at the top then, and I need to be careful, this guy, this point here, if I follow it up, is at the same height as that edge. So that just scooches across there. And it is joined, sorry, no, it scooches further than that. Oh, he's off again. It goes to there. The dog, by the way, is seeing dogs on the telly, and he's protecting our house from the dogs that he thinks that are going to jump out of the telly at him. And that's why he's barking, or he is listening, or he's watching the front window and looking at different dogs walking past and having a fit because they're passing out his house. And as far as he's concerned, he's the boss. Anyway, you didn't need to know that. Now, looking in from this edge, I need to put this line in as well, but this is dotted because it is at the back. And there we go. Now, just before I leave that one, I'm going to turn it back this way so you can see it. Right. Now it looks weird again. Now it looks peculiar. But what I want you to remember is we're literally drawing an elevation in the same way as you would always have done it. Okay, last question. And normally I wouldn't do this one with you too often. I would just check your answers and so on. But just to make sure that everyone is okay. This is my x-axis here. And it's positive there. It's negative at this side. It's positive here. It's negative at this side. Now, mind you, they have given us... Oh, God, the dog. They have given us -1 and 1, so out to -1, up to 1. And they've given us 1 and 5. So therefore, where is 3, 2? So 1, 2, 3, 1, 2, it would be here. And so on. So 3, 2, 1, 2, 3, 4, 5. This would be D. 6, 1, E. 1, 2, 3, 4, 5. Am I right? I am. And then the last one, F8, 6. 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, and that is it. All right, I hope that has helped. It's important you do those, and it's important you take note of how they're done, and please submit them to me. Okay? All right, guys. Thank you very much. What's wrong with you?